Hello everyone, welcome back to my YouTube channel. My name is Mr. Hussein Mwasapi, and in today's video we'll be looking at rate laws. Alright, so before we begin, don't forget to like and subscribe to the channel. Okay, so what are rate laws? So rate laws are very simple to understand. That's something you should know. So I'll explain them in the most simplified way I can find. So rate laws are simply just laws that help us to predict future reactions. That is, if we know the initial conditions of the reaction. Not only that, they also help us know which reactant will disappear faster than the other. Now, since our main focus are reactants, then we should bear in mind that rate laws entirely depend on the reactant's concentration. What do we mean? Let's try and understand this with basic illustration. Say we have a reaction such as A reacting with B producing C. If we want to determine the rate law of this reaction, we'll say that the rate law of the above reaction is equal to the rate constant times the concentration of A raised to X times the concentration of B raised to Y. If we had another reactant, we'd say times concentration of the other reactant raised to another variable. Okay, so now this is basically the rate law that we have, the rate law equation to say. So now one thing you should know is this: when it comes to questions, mostly the formula is written as rate being equal to the rate constant times the concentration of A raised to X times the concentration of B raised to Y. So this is basically the equation that we mostly use. So now from the equation, one thing you should know is this: K is what we call the rate constant, and X and Y are simply just the orders with respect to each reactant. Orders with respect to each reactant. So be mindful that rate laws help us determine which reactant disappeared faster than the other. Don't forget that point. So this is the equation: rate is equal to K, concentration of the first reactant raised to X times the concentration of the second reactant raised to Y. So now one thing you should also know is this: that rate laws can be determined stoichiometrically or through an experiment. So questions might be given under stoichiometric problems or experimental type of problems. So let's put that to mind as well. So now let's try and understand the possible questions that we might come across under rate laws. So let's learn how to determine some stuff. Say to determine, for instance, the rate law, the overall order. We could also look at the rate constant, and finally the units of the rate constant. Alright, so this is what we'll look at: how to determine the rate law, the overall order, the rate constant, and the units of the rate constant. So basically the problems we'll be looking at now are experimental type of problems because they're the most frequently found questions. Alright, let's get to an example. So we have a basic example where we've been given experimental data. We have some trials. We have about 3 trials: trial 1, 2, and 3. We have the reactants, nitrogen and hydrogen, and the initial rates. So we're having the given values, and we're being asked to calculate the rate law. So basically what we have to do is simple. Basic steps we have to follow. So we do understand that rate law is equal to the rate constant times the first reactant, in this case which is N2 raised to X, times the second reactant which is H2 raised to what? Y. With this in mind, we can now determine what is needed from the rate law. So from the rate law, all we need to find are the orders and just substitute for them. And in the end, we end up having the rate law that we're interested in. So now what are these simple steps? Step 1, just find the what? The orders. So now we're basically trying to find the orders with respect to what? Each reactant. Because each reactant has its own order. So we can start with the first reactant, which is nitrogen. So for us to determine the order of nitrogen, all we have to do is basically pick two trials where the concentration of nitrogen changed while the other was constant. So basically pick two trials where the concentration of nitrogen gas changed while the other remained constant. Now be mindful of this. This is one way to remember and finding the order. So we need to pick the trial where the concentration of nitrogen changed only, or the other remained what? Constant. So what we're going to do is this. From the given data, we can pick trial 2 and trial 3. Because in trial 2 and trial 3, that's where the concentration of nitrogen changed. So we're having trial 2 and trial 3 because only the concentration of nitrogen changed while the concentration of hydrogen was constant at 0.2 and 0.2 there. So what we'll do is that we'll say rate 2 will give us a law of K times the concentration of the first reactant raised to X times the concentration of what? The second reactant, which is H2. Write this properly. H2 raised to Y. This is going to be ratioed out with the rate law of rate 3, which will be the same thing. N2 to the X, then H2 to the Y. So basically what we'll do is this. We'll first simplify and then try to make it in a way that is relatable. So you're having rate 2 over rate 3 being equal to the ratio of the concentration of nitrogen from rate 2 divided by the concentration of nitrogen from rate 3, and the order of this is raised to the order of X. Then multiply by the concentration of hydrogen from rate 2 by the concentration of hydrogen from rate 3. And all this is to the order of what? Y. If we substitute this from rate 2, we're having the value of the rate, which is the initial rate, to be 0.36 over the initial rate of rate 3, which is 1.44. This is equal to the rate of nitrogen from rate 2 is simply 0.1 over the rate of nitrogen from rate 3, which is 0.2 raised to the X, times the rate of the concentration of hydrogen from rate 2, which is basically 0.2 over the concentration of hydrogen from rate 3, which is 0.2. I know this is raised to the order of Y. Now the one which will just cancel out and now give us the one giving us a 1 when we simplify is basically the one that will cancel out. So we're not interested in hydrogen, we're basically interested in what? Nitrogen. So hydrogen cancels out because 0.2 divided by 0.2 is basically going to give us 1, and we'll just exclude Y because our interest is N. So this gives us, if you divide 0.36 by 1.44, you end up having 0.25. And this is equal to 0.1 divided by 0.2, which would be 0.5 raised to the order of X. So basically this is 0.5 raised to X being equal to what? 0.25. So now this can be solved using basically indices. This is the same as half to the x being equal to 1 over 4, just like that. And we do understand that this is the same as 1 over 2 to the x being equal to 1 over 2 to the power what? 2. So this cancels with that, and you have x being equal to what? 2. Now others are not comfortable with this. Others would use logs to say. So remember, just a quick recall from logs. If you have a raised to b being equal to say the answer, this is the base, this is the power, and we basically know this is the answer. So if you want to convert this into log, this is the same as log base times answer is equal to what? Power. So we can use this trick to determine the value of x. So we can pick it from, let's pick it from this point here. Yeah, or I can pick it from this point here. So let's pick it from that point, this one here. So we're having 0.5 to the x being equal to 0.25. So remember log base, so we say log, the base that we're having is what? 0.5. Log 0.5 answer times 0.25 is equal to the power, which is x. So x is equal to log of 0.5 times 0.25. So you have to convert this. You can say x is equal to log of 0.25 over log of what? 0.5. And if you compute this on a calculator, then you get the order of what? 2. So once you do this, then you have found the value of x, which is the order of the first reactant that you have, which is what? Nitrogen. So therefore you could say that nitrogen 2 as a second order of 2. So we just say this is equal to what? The second order. And this is the first order that we needed to find. Now once we find for nitrogen, we now need to find for what? Hydrogen. Let's do the same. So for hydrogen, all we need to do is the same that we did with nitrogen. Let's pick two trials where the concentration in this case of hydrogen were changed while the other remained what? Constant. Remember, we need to pick two trials where the concentration of hydrogen changed while the other remained constant. So in this case, I'll pick try 1 and try 2. So this means I'm having rate 1 ratioed out with rate 2. So rate 1 gives me a rate law of K times the concentration of the first reactant, which is N2 raised to X, times this is 2 times H2 raised to what? Y. Ratioed out with rate 2, which is over K. Then we have N2 X times what? H2 Y. So this cancels out, and you have rate 1 over what? Rate 2. And this is equal to the concentration of nitrogen from rate 1 divided by the concentration of nitrogen from rate 2 and raised to the order of X times the concentration of hydrogen from rate 1 over the concentration of hydrogen from rate 2 raised to Y. All we need to do now is substitute. So we're having 0.18 as the initial rate of rate 1 divided by 0.36 as the initial rate of rate 2 being equal to what you are having as a concentration of N2 from rate 1, which is 0.1 over 0.1 to the X times for hydrogen we're having basically 0.1 over 0.2 raised to Y. So remember, our interest in this case is Y, so X is excluded, and now we only have 0.18 over 0.36 being equal to 0.1 over 0.2 raised to Y. So if you begin to follow out, you'll be having basically 0.5 this side being equal to 0.5 the other side to Y. So this is like 0.5, Y being equal to what? 0.5. So you can just apply indices or logs, either ways you still get the answer. So you have 1 over 2 y being equal to what? 1 over 2 to the first power. So this cancels with that, and you drop the powers. Y is equal to what? 1. So this implies that the concentration of hydrogen, or the reactant hydrogen, has the first order. So this is equal to what? First order. Let's be mindful of what we've just done. So now, what we have to do now is this. So what we have to do is now write the rate law. The rate law. So now the rate law, remember, is equal to K times the concentration of the first reactant, which is N2 raised to X, times the concentration of the second reactant, which is H2 raised to what? Y. Now we know that from what we have found, we understand that X is equal to what? Yes. X is equal to 2 and Y is equal to what? 1. So all we need to do is to substitute and just say rate law is equal to K, changing concentration of N2 raised to the second power times the concentration of hydrogen 2 raised to the first power. And this is basically what? The answer for the rate law. If you want, you can remove the 1 and just say the rate law is equal to K times the concentration of N2 squared times the concentration of what? Hydrogen. And that's your final answer. Now let's try and look at a different question that they might bring. They might also ask us to say, find the overall order. Now the overall order is simply just the sum of all orders. The sum of all orders is what we call the overall order. So this implies that the overall order of what we are having, this experiment, is equal to X plus what? Y. So overall order is equal to the value of X, which is 2, plus the value of Y, which is 1. And the overall order now will just be 3. And that's the final answer. So it's quite simple to find the overall order. Now let's look at a different question that we might also come across. Say we've been asked to calculate the rate constant K. So here all we have to do is simple. Remember, the rate law can also be written as rate is equal to K, the first concentration N2 raised to the X, times the second concentration, which is H2 raised to the Y. Now since we already know the values of X and Y, we can say rate is equal to K N2 to the second times what? H2 to the first. So no need of showing it. Now we need K, so we can make K the subject formula, of which we all know how to manipulate this. So this will just give us K being equal to rate, because we have to divide both sides by the concentrations. So this will give us rate being equal to the concentration of N2 to the X times, sorry, let's not put the X, we already know what it is. So it's 2 times the concentration of H2 to the first power. So basically have that. So now once we have this, all we need to do is to just pick any rate and substitute. Pick any initial rate and substitute. And just plug. So for simplicity's sake, I'm going for trial 1 because it has smaller values. So in my case, I pick trial 1. So I have K being equal to, what's the initial rate of trial 1? We're having 0.18 over, what is the concentration of N2 in trial 1? That is 0.1, so it's going to be squared times that of hydrogen, which is the same, 0.1. If you compute this, you will basically end up having 0.18 over 1 times 10 to the minus 3. So K will end up having, or being, say, 180. Now we need also to include the units. Alright, so let me show you a trick in finding the units. So to find the units of K, basically you just use this formula. K units is equal to m to the power 1 minus n times s to the minus 1. So in this case, where n is equal to the what? Overall order. So in our case, we already know what the overall order is. So we say k is equal to 180 times m to the power 1 minus what? The overall order. In this case, the overall order was found to be what? 3 times s to the minus 1. So we can simplify and have k being equal to 180 times m to the minus 2 times the s to the minus 1. And this is the value of what? The rate constant. Alright, so this concludes all the possible questions that might come and experimental problems of rate laws, but we'll look at more examples in future videos involving rate laws so we can clearly understand this. Alright, thanks for watching. My name is Mr. Hussein Mwasabi, and don't forget to like and subscribe. If you have questions, reach me on WhatsApp on the number that is on the screen or in my description. Remember to strategize before you become a statistic, and let's try and push for that A+.